Retrieval-Augmented Generation, or RAG, has seen widespread adoption, particularly among companies leveraging AI for better information retrieval and response generation. There has been a significant advancement in this space, and the one that I will be talking about is called the Agentic RAG. Traditionally, our RAG system follows a very linear structure, like shown in this diagram. Let's say we have some PDFs here, and all those PDFs are fed into the embedding model. This embedding model will create embeddings. These are the numerical representations, all right, that captures the semantic meaning and the contextual understanding from the data. This data can be anything, text, information, images, or audio files, all right? And all those embeddings are then stored in a vector database like the ChromaDB, the Pinecone, Elasticsearch, and more, all right? When a user puts in a query, a similar information is then searched and retrieved from this vector database and is fed into the large language model along with the prompt, and this large language model will generate the response. Now in this case, this foundation model is not relying on its existing pre-trained knowledge base. It is using an external knowledge base, which is in this case a PDF, all right? So what happens when you put an agent in between these vector databases or any other databases and these large language models? These agents have particular characteristics, all right? The first, they can interact with the foundation models or a large language model, all right? They have a memory. It means they can understand and learn from the past conversation. Based on that, they modify their multi-step reasoning and call upon certain tools. These tools can be anything. These tools can be an SQL database or a vector database, a web search, or any other API call, all right? When a user puts in a query, this query is then fed into the agent. Based on the multi-step reasoning, it decides which tools to call, all right? Okay, now let's see the practical implementation of this Agentic RAG. So here we have a user interface for an application that I built with Streamlit. Before moving on, I just want to talk about a couple of things. The first one is the Agno. It's a library that I've used to build these agents. Second, I'm using this Gemini Flash 2.0 model as a foundation model. I'm using Gemini embedding model, which I believe by default is text embedding 004. So in a search type, I'm actually using a hybrid approach, which will use the dense retrieval and sparse retrieval for accurate retrieval of context from vector database, all right? There are some tools that I'm using. The first one is the DuckDuckGo tool, which is a web search tool, which is not the best, but it works, all right? I'm using a calculator tool here because the model itself is not very good with calculations, so it is better to give it a external tool, all right? This Y-Finance tool will help the agent to get real-time information, stock, financial information of any company. This SQL tool will help the agent to interact with the SQL database. In this case, I'm using an example SQL database right here. And this one is the instruction that I've given to the agent that it will follow before performing multi-step reasoning, all right? This part will store all the conversations that happened between user and agent, and it will retain all the conversations in all sessions, all right? It will help the agent to learn from the previous conversations and generate more customized and relevant response, all right? In this case, I'm allowing agent to use last 3 conversations, and I can change this to any other digits. Now let's get back to the interface. Now let's start by uploading a document. So this document is about a Tesla. It's a financial summary for 2024. Okay. Now I want to see the total production of Tesla for 3rd quarter and 4th quarter of 2024, all right? Search the knowledge base for total production of Tesla for Q3 and Q4. This will so the agent will search the knowledge base and try to retrieve the relevant information. In this case, it has given us two values. The first one is for the third quarter and the second one is for the fourth quarter. Now I want to calculate a percentage change. Alright, for this to happen, the agent will use a calculator tool to calculate the value. Alright, use calculator tool to calculate the percentage change for values generated above. Now agent is using a calculator tool and it has given us the values. Alright, there was a decrease of about 2.2% in the production compared to previous quarter. Alright, now I want this agent to use a financial tool to get me the latest stock price of Tesla. Get me latest stock price of Tesla. This time agent will use a different tool, a financial tool. Alright, right here it is using a different tool to get the stock price. Okay, so the stock price is $269.1870. Alright, now I want this agent to search the web and to get me a summary of this company, Tesla company. Search the web and get me a summary about Tesla. Alright, in this case the agent is using DuckDuckGo, which is a search tool, and it has generated some summary. Alright, right here. I've also connected an SQL database with the agent. Alright, get me how many tables are there in SQL database. Okay, there are 11 tables and it has also given us the names of these tables as well. Alright, as you guys have seen how these agents work, if implemented successfully, these agents can help companies reduce their cost, improve their performance, and it can also save a lot of their time.